In this section, we're going to begin looking at systems of three equations with three variables. You are used to finding where two lines intersect, hopefully at a point x comma y in the intersection there, but now we're going to be having three planes and they're going to intersect at an ordered triple, triple, which is of the form xyz. Now geometrically, this is what we would prefer to have, three planes meeting at a single point, but that's not always going to be the case. As you can see in these three pictures down below, it's possible that we can result in no solution. In this case, we say the system is inconsistent. There is no single point or triple where all three planes intersect. It is also possible to have infinitely many solutions, as you can see in the pictures here at the bottom of the screen. In this first and second case, the planes all intersect in the form of a line, and so a line will be the intersection place here. And in this final case, we actually have three planes coinciding, and so that will be the one plane itself will be the solution set. In this case, we say the planes are dependent, or the system is dependent upon each other because they're not totally unique. So in this chapter, or in this section, we're going to learn how to deal with these different cases that we have here. Now this may seem to be a trivial type of problem, determining whether these ordered triples actually are solutions to the system, but this is a key type of problem because this is the way we check our answers. So for part A, we wish to take this first triple, 2, 5, -1, and check it in each of these three equations. In other words, is 2 times 2 minus 3 times 5 plus -1, is that question mark over my equal sign equal to -12? Well, we find out that we have 4 minus 15 minus 1, which is -12 on the left, which is equal to -12, so it works in the first of the three equations. Now we need to take the 2, 5, -1 and substitute it into the second equation. We would have 2 plus 5 minus 2 times -1. Is that question mark over the equal sign equal to 9? Well, 2 plus 5 is 7. This will become plus 2, and so yes, we do have 9 equals 9, and it works in the second equation. Now let's take the 2, 5, -1 and substitute it into the third equation. We will have 3 times the 2, -3 times the 2, plus 2 times the 5, minus z, that's minus a -1. Is that question mark equal to 7? So here we go again. -6 plus 10 plus 1. That becomes 4 plus 1, which is 5, which is not equal to 7. Doesn't work there. So no for point A, or part A. Now we move on to part B, where we're going to do the same thing over again. This time we're going to be substituting in the point 1, 4, -2. Now I've zoomed in a little bit further. So here we go. Part B. Substitute into the first equation first. 2 times 1 minus 3 times 4 plus a -2. Is that question mark equal to -12? Well, we get 2 minus 12 minus 2, which is -12, equals -12. So yes, it works in that first equation. Now let's substitute in the 1, 4, -2 into the second equation. We will have 1 plus 4 minus 2 times -2. Is that question mark over the equal sign equal to 9? Well, that becomes 5 plus 4. So yes, 9 is equal to 9, and that checks in the second equation. Finally, let's take the 1, 4, negative 2 and substitute it into the third equation. That will give us negative 3 times 1 plus 2 times 4 minus a negative 2. Is that question mark over the equal sign equal to 7? Negative 3 plus 8 plus 2. The left side is 7, equal to 7 on the right. And yes, it turns out that 1, 4, negative 2 is a solution to this system here.